Yeah, we're live. 7:04. A couple minutes. I got stuff going on. First thing I want to do is, before I get going, I want to recommend a book to you guys. There's lots of cool stuff. I was just taking a look back, and I've had this thing for a while. It's this right here. Let's see if you can get it. Ferrari Formula One. It has a lot of very technical stuff in here, including the thing that I like most. I mean, there's a lot of really good stuff on transmissions and suspension and aerodynamics and all kinds of in-depth look at. This was a basically circa 2000 Ferrari Formula One vehicle and all the performance, because this was written, you know, long after they'd already gone to higher levels of stuff. So, but this is very cool because especially in the engine deal, one of the things I liked that they covered in this was the effect of, because in Formula One you pay attention to absolutely everything. Everything is a balance with everything else, with the weight and the position and the center of gravity, and how much it weighs and where that weight is and how high it is, and it's all amazing what the things that they have to consider. But on one of the things I thought was really cool on the engine development is obviously they're taking a look at the. I've got a sticker or something. I think it's feels like an aluminum splinter in my toe here. One of the things that they're looking at that I was reading about was the airbox design, because they're looking at basically sealing the engine, and then because of the vehicle speed that they have, they're getting pressurized air to help power improvement. And they were showing, they have it graphed, the power improvement versus vehicle speed, and then the pressure that they're applying to that air inlet system. So at a maximum speed, which is what they would get at some of these higher speed courses, was 350 kilometers an hour. They were improving the power output of the motor by 5.8%. So in this case, it was going from 817 horsepower, basically. This was a 3-liter naturally aspirated V10. And they go into why they chose the V10 over other things and why it's a compromise in terms of harmonics. I mean, there's a lot of really good stuff here. But they went from 817 horsepower to 866, so almost exactly 50 horsepower, but only at that maximum speed. But they show you the trajectory of the improvement in power versus road speed. So it's really cool stuff. And that's only one of the things. They're showing sliding trumpets and injector position and just all kinds of stuff. So it's really in depth. So it's a even though this is information that came from Formula One back in 2000, and obviously we've come a long way since then. What we look at as far as performance, especially from a junkyard motor, this stuff is is on a whole nother level. They cover specific power outputs, and one of the ways that they break that down, which is really cool, is the specific power output that they've made, and they can show you over time, like, hey, back in the early to mid 50s, a Formula One motor was making about 100 horsepower per liter. And it wasn't until way later that they got to 200 horsepower per liter. And at the end of this development, well, when the book was written for the 2000 vehicle, they were getting up near 300 horsepower per liter for a naturally aspirated motor. That's really, really impressive. And now I'm sure that they probably have reached that number. But the interesting parameter that they gave is its specific output per engine speed per 1,000 RPM. So it's almost like a specific torque output. And it's really, really kind of consistent through the years. Like they were able to achieve, a fairly good specific torque number. But what they've done is they just keep increasing the engine speed. So they just keep making that farther and farther out, and they make more power in doing this. And they go into all of the things that they have to consider when they're going up in engine speed. And it's just a lot of good stuff. It's a lot of really good technical information. So if you're interested in that kind of stuff, I highly recommend that book. It works out very well. Now we can get to the discussion. You can see the thumbnail that I put up was the 2.2 liter Chrysler motor. And so what I want to talk about a little bit tonight is, what do you guys think? In fact, that's going to be our poll for tonight. On the 2.2 liter, I'm going to ask this early, and I'm going to try to be doing that with the polls from now on. So we'll get it up there and so people can take a look at it. On a Dodge 2.2 liter turbo motor, is the cylinder head holding back the power production? Well, I mean, I can't put all this in there, or is it something else? So this is kind of a yes or no question, the way that they have the poll set up. But is the cylinder head the thing that's holding back power production? in that 2.2 liter Chrysler motor. So let me know what you guys think. Is the cylinder head flow holding back power? So I rephrased it. Is the cylinder head flow the number one thing holding back power production in the 2.2 liter / 2.5 liter Dodge turbo motor? There we go. Is the cylinder head flow the number one thing limiting power production in the 2.2 liter, 2.5 liter Dodge turbo motor? So we're going to ask the community and see what you guys think. Because as we look at that, this was, basically, back in the 80s performance. So back with Madonna and Thriller and stuff. But it's interesting if you look at the 2.2 liter turbo motor, it did very well. If you look at its the combinations that they put together for that Dodge Omni GLH and then the Charger and the other vehicles that they use the 2.2 in, the LeBaron and stuff. If you look at the performance of those vehicles, especially like an Omni GLH or especially the GLHS, the 175 horsepower version, that thing would more than give the Camaros and Mustangs, 5-liter Mustang stuff, a run for their money. It was that kind of performance back then, which is, was fairly stout. And obviously guys have, since it's a turbo motor, you could obviously turn the boost up. Now the intercooled version was a good bit better than the non-intercooled version, not just because of the intercooler, but because of the intake design. And they had learned a lot of things on the management side. And so it was a better combination. The intercooler allowed them to turn the boost up. It allowed them to turn the timing up. The early turbo stuff was early turbo stuff, and they had, there was still some learning curve there that they were doing with the Dodge. But the reason that I ask about the cylinder head is because unlike a lot of stuff and things that came later, this was not a 4-valve head. It was a 2-valve head, and it was a 2-valve head that when you take a look at, when you're not like one of us, but when you're an OEM person and you're one of the people that are in making the decisions on how much power this thing needs to make and how are we going to get this, and then how does that correlate with all the other things that are necessary for what we're doing, fuel mileage and we have to limit maintenance and we have to limit warranty stuff and cost. And there's a lot of other parameters that go along with that. So how do we reach that? So when they do that, when they're designing the motor, they design the motor to fit in all those criteria, not just like, hey, how I'm sure that it's never, maybe by some of the engineers that are outside the norm, but I'm sure that nobody ever thinks, hey, you know what, we should really build this thing and leave a whole bunch of power on the table so that these guys could then, the aftermarket guys, the guys that want to go fast, can actually turn these things up and wick them up and really go out and put a hurting on the Mustang and Camaro guys. I would like for the engineers for that to have happened, for that to be a reality, but I don't think that it is. I mean, I think that their hands are kind of tied in some of these things. So they grab stuff that's readily available, that's the most cost-effective way to make the thing happen that they have been asked to make happen. So I'm sure other issues were important, limiting detonation and air temperature and, getting the turbo to last for 100 or 200,000 miles, whatever their longevity goal was. All of those things, they have a lot of things that they have to a lot of people that they have to answer to, and then a lot of questions that they have to answer, and a lot of goals that they have to achieve. That has nothing to do with, hey, I need to make 146 horsepower from this turbo motor. Well, can we do this? Well, yeah, all we have to do is take what we have already that we have laying around, and we just add this little turbo to it and run 7 pounds, and look, it wants to make more than that. So we're gonna limit it with timing and stuff. So they're able to do that, and then along the way they discovered intercooling, and then they would eventually try 4-valve stuff with both with the Maserati version and with the Lotus version. And naturally, that those versions, if porosity is not a problem and stuff, that any sort of modern 4-valve deal is a lot better than that 2-valve deal. But that my question still holds in the poll. Is the cylinder head the thing that is holding it back from making power? So you think about it this way: if I had all of the other things that were stock, and I just ported the head and made the head flow better, like let's say I could port the head to make the head flow 200 CFM instead of whatever it flows now, and then leaving the stock cam in there, leaving the stock intake manifold in there, is that going to help me a lot with making power? Is that the thing that I need to concentrate on? And just so people are aware, normally cylinder head stuff, especially with anything modern, if you look at the questioning, if you pose that same question to an LS guy, obviously the cylinder head is not what's holding things back, and certainly not in a turbo application, because we know with any kind of stock head that if you just put a camshaft in it and springs, and then you add boost to it, then you can do marvelous things, like just ridiculous kinds of power level. Can we do that with a 2.2 with just the cylinder head? Or do we need to look at other things on it? And for me, in looking at that, in this posing this kind of question, because I get asked this kind of question a lot. Okay, what if I did this? With the questions with camshafts. Okay, Richard, I want you to do a test. Can you just change the lift? What happens if you go from 550 lift to 600 lift and don't change anything else? Well, you can do that. I don't know why you would. If you were going to go to the trouble of putting a camshaft in, I don't know why you'd keep it at 191 degrees of intake duration, like an LM7 cam, and then go to 600 lift. First of all, that probably would be a bad combination, because it'd have a lot of ramp rate with so little duration and so much lift. The thing would have to go basically straight up and come straight back down, which is not good for stability and RPM. So there are reasons that combinations of cam, lift, and duration of LSA kind of go together, because they're all also trying to stabilize the camshaft. So, and then doing one thing is usually not the answer. And this is especially the case of things that we see from the 80s. So a good example is a 5-liter Mustang. So if we pick a 5-liter Mustang and go, hey, if we change, we know that the heads are restrictive, right? We know that an E7TE head or an 86 head, when they first started fuel injection, we know that that's very restrictive. So if we change the head, are we going to get lots of power? Well, yeah, it will improve, because if you put a trick flow head on, or a GT40 head, or a GT40X head, or a Airflow Research 165, or any kind of head on there, it's going to like it and improve it a lot. But it's not going to do very well if you put an Airflow 165 head on, or a 170 11R trick flow head on there, and then you have a stock HO manifold and a stock HO camshaft. The cylinder head's going to be going, hey, what's going on here? I'm here. I'm ready to do my stuff. What's with this intake and what's with this camshaft? Because they're not allowing me to do what I know that I can do. It's like hampering a runner with hooking them up to a trailer or something. It's just not going to work very well. So, and I think that in looking at the Dodge motor, certainly the non-intercooled version that I have, the 2.2 that I got from an 84 600, I think we got it from, the one that I'm going to be running first. If you look at that motor, and I get this question a lot, like I said, I get individual things. Hey, what happens if I just did this? Because the cylinder head that David Vizard is porting for me, and if you guys haven't watched David's stuff, you need to go check out his channel, because he's, if you want to learn about porting and airflow and making power and stuff, he's got a lot of good information there. But if we just take his ported head and put it on this otherwise stock kind of motor, I just don't know. I mean, I know it would gain power, and it would allow us, it would gain NA power, and it would allow us to make more power per pound of boost if it gained NA power. But we would be limiting what the head has the potential to do if we still had a stock camshaft in it. And in that case, and especially on that one, on that 84 or 85, with the non-intercooled log style intake manifold. So if you ever looked at an exhaust manifold, a stock exhaust manifold, the Dodge Ram Hemi is a perfect example. It's terrible. It has no like runner length. It's just a big log. It's done for fitment and packaging. It fits really close to the head and basically just has a channel for all the exhaust to go out. Well, that's what the intake manifold is like on these Dodge 2.2s on the non-intercooled versions. They made big strides when they went to the intercooled version of the motor, and then the one-piece and the two-piece manifolds I think are similar, and we're going to try to test both of them. But those are a big step up because they actually have runner length and a common plenum and a little bit bigger throttle body and stuff, I think. But those are actually real manifolds that you would recognize as manifolds. This turbo inlet manifold looks like a log style exhaust manifold. And I think that they, this is early on in the turbo development. So they just probably didn't know, or that's what they that was the design that they came to by packaging and making it all fit. Okay, we have to put the turbo here, we have to put that here. If we just bend that there and it's all packaged in and that will fit all tight, we can put the whole thing in, it drops in easy in the cradle and all that stuff. So again, we don't know what their thinking was when they were designing that. It's far from optimum, and there'll be big power gains to be had from replacing that intake manifold with even the later Turbo 2 manifold with the intercooler on it. And irrespective of the intercooler, just the manifold itself is going to definitely gain power. And I'll be making a custom one as well. So I think in the case of our pole, the head alone, like a 5-liter Mustang from the 80s, is probably not going to be enough. I think it needs other things, and it certainly needs a camshaft, because almost you would be right probably 80 or 90% of the time if somebody asks you what's the first thing that you should change in the motor. Camshaft is almost always it. It certainly is in an LS. Maybe not in a Coyote, especially a newer Coyote. Boost is always the answer. That's the first thing. But camshaft for an NA motor is almost always it, because the cam timing for the factory stuff is almost always mild. They do that purposely because they have other goals besides power. We need to make our power, and we've done that doing this kind of cam timing. The thing also needs to idle like at 600 RPM. It has to have good drivability. It has to get good mileage, and the camshaft plays a big part in a lot of that. So they select the camshaft so that it does all those things, and that's why, like in an LS or even an LT, in some of these motors that you put a camshaft in, you look like a hero because you pick up a lot of power, because that's the only thing that's missing. They've realized that if I put good cylinder heads in them and I put a good intake manifold on there and I kind of limit them with camshaft and get the drivability, I can make the power that I want. It has, it runs around, it does all things it's supposed to do. And then for us, it's kind of nice because then all we have to do is put a cam and springs in it, and then we look like heroes. And then if you had boost on top of that, we looked like a double hero, which is awesome. So on the 2.2, I honestly think that one thing is not going to change it. Obviously, it already has a turbo. We could put a bigger turbo on. We can add more boost. I think on that, in this case, probably intercooler might be my first recommendation for that. But to do an intercooler, unless you get really tricky with the position of the turbo and the way that it's aimed, and it's certainly on an 84, you almost have to do the manifold too. And that's the most common thing on that 2.2, is that you would do a new manifold so that you could blow into it. Because on the 84 and 85, you're actually drawing through the throttle bodies in front of the turbo. So the throttle body opens up, and then the air goes through the throttle body into the turbo and then into the manifold, which is unusual. Usually you have air going through a mass air meter or something into the turbo, and then that turbo blows through the throttle body and then into the manifold. So we're throttling the compressor, as it were, on this, which is kind of cool. And I want to try different size throttle bodies on that naturally, because the air going into the turbo is going to be important. But since the opening of the turbo is about this big and the throttle body is, is already big enough, if I put a 105 millimeter throttle body on there, we're going to get some diminishing returns, because the opening is going to be this big and the turbo is like, hey, I'm only this big, so it doesn't matter how big. You just open the thing up and not have a throttle body there at all, and I can only do so much. That will come into play more when we add bigger turbos and stuff. But by the time I do that, we'll already have the right kind of intake manifold and throttle body on there, and then we'll be blowing from the turbo. We'll be blowing through an intercooler into the manifold, like God and nature intended. So honestly, on the 2.2, I think like the 5 liter, and they're both from the same era, basically. I think what you have to do is change essentially all 3 of the things. If I was picking one thing, I would do intercooler. I would do turbo and intercooler. That way you could turn the boost up. And maybe even before the intercooler, I think I'd select E85. So you'd have to put bigger injectors in it, but then run E85. And E85 then, even in non-intercooled form, would probably take you a long way. You might get more power potential from E85 than you could from a ported head or a camshaft. Maybe an intercooler also. I don't know. We'll have to see. So I think for that particular application, boost tends to be the answer on a factory turbo thing. More boost is really the way to go. So E85, intercooler, and then I would start worrying about maybe camshaft. The factory camshaft has to be really, really mild. And in the case of that early one, it's a flat tappet cam. So we would do cam and springs and that. And then an intake manifold, definitely I would want long runners, because this thing is like a 6,000 RPM motor, and that's where it wants to run. So having a log style manifold with a 1-inch or 2-inch runner in it, whatever it is effectively, is doing basically nothing. There's no reflected wave gain from, I'd have to look at the secondary and tertiary waves to figure that out exactly, but there would be almost no gain from having a runner length that long. And so having something that has lots of runner length. In fact, I'm going to make some, when I make the manifold for it, I'm going to make some long ones, because a 6,000 RPM motor is going to want more runner length than even the factory stuff has, I think. I suspect. We'll find out. I'll make it adjustable so we can try it, so we can figure out what it's doing, what it wants to do. And then if you want to run camshaft and ported head and more engine speed, then you start trimming the manifold runner length. The tubing that I use will be big enough to flow more than enough air. The intake manifold will likely flow more than the cylinder head does, even in ported form, and that's not going to be hard to do, because I get to just select whatever size I want. So I could select the 1 3/4 or 2-inch or whatever I want to make it work. The only thing is, you don't want to go too big and then have it mismatch with the opening and the head port. So that wouldn't be good. So let's see where we are on our poll here. Pretty close. Is the cylinder head flow the #1 thing limiting power production in the 2.2, 2.5 Dodge turbo motor? 59% are saying yes, and 41% are saying no. So it's still skewed in the yes form. That's interesting. I'm excited about running the 2.2 only because I like boosted motors, obviously, but there are so many things that I can test as soon as we get that thing running and it's working. There's lots of cool, like, small individual tests, like I said, throttle body sizes and different kinds of fuel, and all turbo sizing, intake manifolds, camshafts, all kinds of stuff that guys want to know. Because the problem with these 2.2s is that they were kind of hampered by having to deal with the factory electronics stuff. The guys would put bigger injectors in them, but the problem is there wasn't a lot of data logging going on, so people didn't know, well, how much timing was on that run. I don't know. We just ran it. So we want to have all of that data to show people, hey, look, it wants to run at, I'll just pick a number, 20 degrees. It likes 20 degrees with the 85. It likes 25. It likes 15. Whatever it likes, we'll find out, and we'll know. And then you have to run, we'll run the boost up, obviously, after we get to a point where that's okay. And then I think after we optimize the combination with the intake runner length that we want for the RPM that we want, and the cylinder head flow and a camshaft, the thing should make pretty good power under boost because it's going to make even better power NA. So let's see what you guys got going on. I'm actually going up tomorrow and meeting Todd. I ain't no punk. We're going to be taking a 5.3 out of a truck tomorrow. so that will be fun. You know, there's nothing better than yanking motors out of a beat up old truck, which is good. And we'll obviously use that. It sounds like it's a runner, so that's something that could go down and do, you know, do some dyno mule testing would be good. How much boost you can run on the 8-valve? I don't know. We're going to start off with low. I'm going to start out at 7 pounds. What I want to see, like I have different goals. A lot of people think that the thing that you need to do is how much boost can you run, and how much power can you make. That's almost never my test regimen. Sometimes on the big bang stuff, and even then, it's not to make the most power that we can. It's to find out how much power that particular thing will take. You know, how much will the rods take? How much will the pistons take? That sort of thing. Not I'm building a race motor and I need it to make as whatever the number is, like as much as possible. Because I get a lot of people tell me that, well, I want to make as much as possible. So then you want to build a top fuel motor. So you want to build something that makes 10,000 horsepower. Well, no, I need to drive it around. Okay, well then it's not as much as possible. That you need to pick a different number. Give me, you know, let's come down into reality. But on my first goal is to get it running and make it work and have it take boost and cooperate and not break. The goal after that is the one that I have personally is I want to see this thing make 200 flywheel horsepower at 7 pounds of boost. And I think I can do that with the right intake manifold and the right intercooler and E85. I think that will happen. And so I want that to be my good starting point. But no camshaft, no cylinder head, just a stock head, stock camshaft. I just want to do it with, it would be nice if I could do it non-intercooled or with the junky, like non-intercooled manifold with an intercooler and then just reclock the turbo and make all that work. That might work. I think it's going to have the T2 intake manifold, which I'm okay with. I have those to test anyway. So I have a 1-piece and a 2-piece version, so we can run both of those. But I think that motor with the stock turbo and a good sized downpipe and E85 and 7 pounds of boost, I want that thing to make 200. That's my first goal. And then we'll do timing tests and we'll do boost tests and we'll do fuel tests because I'll run it on 91 because obviously lots of guys are running on 91. We'll do that stuff. We'll do an intercooler test. We'll do non-intercooled versus intercooled. I'll have big enough injectors in it where we can make lots of power where that won't be a problem. We'll do the log style manifold. We'll do the 1-piece. We'll do the 2-piece. We'll do a super Richie version later on. And so there'll be a lot of cool individual tests, and hopefully it should help people and answer a lot of questions, just like we did with the 8.1 right now and the 3800. And, you know, I did endless testing with the 3800. So there'll be a lot of stuff on the 2.2 and also on the 2.5. Okay, let's see what you guys got going on. I'm CAD designing an intake manifold for my Dodge, going to test 3D print it and then cast it in aluminum. Nice. Might be fun to run compounds on a 2.2. I used a Mopar factory reprogrammed computer. Did you use the Super 60 deal? Let's see, Mikey Paul. Hey, Richard, been looking at the small turbos for the Honda Insight, 1 liter, 3-cylinder. Guys use GT12. Some are using GT15s. I've seen the compressor wraps on the GT12s because when I was looking for stuff on the Sprint, we were looking down at some of those smaller ones. I know you're into old Hondas. I wish I could get some of your thoughts. I would look at the GT12 and see what I don't know what the Honda Insight power level is. I don't remember off the top of my head. We were just going to get that motor out of there and put something else in it. But just figure out what you want, what the NA power output is, and then how much boost you want, and do the multiplication. 7 pounds, 7.5 pounds is 1.5 times the NA power output of the 1 liter, and then see where that puts you on the map. go, okay, look, it's on this GT12, it's in the 68% efficiency island or whatever, and just pick the turbo accordingly. It should work out really good. I know I should have a video on that, and I will. Is this the same engine that was in the GLH? Yeah, the GLH had a 2.5 swapped into it. The other motor that I have came from the wrecking yard, the local wrecking yard, and it came out of a Chrysler 600, an 84. 200 flywheel on a 2.2 with boost shouldn't be an issue. I hope not. I hope that it will do that at 7 pounds, though, is the thing that I want to do it on. I want to do it at the factory non-intercooled boost level. 16 valve 2.2 Spirit RT motor. I almost bought one of those, but he had already sold it. The 2.5 T1 is a tough little motor. I live up in Alaska, and just a few modifications. It probably likes the weather up there. Studded tires, nice. The main problem holding the 2.2, 2.5 community back is the gospel of early pioneers. Tiny turbos at high PSI and back pressure negated gains from big cams and porting. They showed gains from stock cams. See, I don't understand that. You don't want to limit it with a turbo size. You want to make more NA power and then put a turbo on there that's going to multiply whatever that new NA power is, as we've seen on every other motor that we've tested it on. That's going to multiply that and make even more power. I want to see the 2.2 Ritchie Ram Charger adjustable Ram tube intake. Let your freak flag fly. Nice. Got lots of alliteration going on there. It will. I'm going to run one that, and I know that the Chrysler engineers did this at one time. I want to run one that loops back over the that crosses over the valve cover, because I think it needs to be that long. I mean, I can make it go straight on the dyno, which would also look cool. It'd be really long, but if I bend it over, it'll be kind of cool. The only thing about looping it over is it might start limiting the adjustability to get down to some of the shorter lengths. Brian, I had to go through my gearbox and my Reliant over the winter. Third gear was grinding. Is it an automatic then, or is it a stick? I just went back through it today. I'll be boosting. Oh, if you had third gear, 16 valve motors are sweet. The RT was I think the fastest sedan, fastest US sedan anyway, in its day. Ever used a 2.2 or 2.5 in a rear wheel drive application? I haven't. I haven't even run one of these on the dyno yet. I think with the 85, it can easily make 200. That's what I'm hoping. I don't see why it can't, but given Guy is in here vigorously taking notes, and we'll sue Richard after this for slander. What? Who's going to do that? Dean, yeah, they I think that's where I got the bell housing from, was from a although it might have been the V6, but they did use that in a 2.5, right? They did have a 4-cylinder in the trucks. If you reconfigure the throttle body and turbo setup, it'll probably work better than the stock setup. The turbo ones weren't set up in the conventional way. No, it was the throttle body's mounted in front of the turbo, so the throttle opens and then the turbo spools up. Brian, my friend Larry made 505 wheel horsepower. That's a lot on a stock RT motor with SC6152, big intercooler, big injectors, and a 3-inch exhaust, and an ECU at 30 pounds. 505 wheel horsepower at 30 pounds on that Spirit RT motor. That seems like a lot. The 2.2 was in the Interceptor. I'm pretty sure. You might ask Brian. I don't think it was a 2.5. I missed the beginning. Is the goal of the build to make a stock PSI stock appearing engine? No, it's what's going to happen with the 2.2 is I'm going to test like everything, ported heads, cams, turbos, boosts, everything. But one of the goals along the way is to run it at stock boost level and get it to make 200 flywheel horsepower with the 85 and probably a different intake manifold and an intercooler. That's why people with 80s to 300 ZXs love the NA to turbo, the 9-to-1, so more compression. Yeah, we'll test different exhaust manifolds and headers and things. My Reliant is an A523 5-speed. Cool. Did the combustion chamber modifications that David did to the 2.2 have an effect on compression? I think he did change the chamber volume, but I don't know what the finished volume is. Rocket Surgeon, the story goes that the original upgrade to the 2-piece intake did actually go over the valve cover. I didn't think about that. I could use the stock part of the stock 2-piece and just make an extension off of that. Although I have the flange already that I can make something off of too. Yeah, the 2.2 was kind of the go-to motor for Chrysler for a long time and almost everything. Richard, when you go to the junkyard, look at the late 90s, early 2000s Toyota Corolla and Camry. They have a nice header style intake manifold. I've seen that with minor mods. They fit the 2.2. Oh, cool. A scary guy named Guy. So why would I have made somebody mad in the community? I'm going to build an interceptor from scratch. Looking forward to the Back to the Future Iacocca 2.2 project. Man, they put out a lot of those motors. Brian, the Interceptor motor was a Cosworth 2.2. Wow. What motor came in the DeLorean? I think that was a Volvo V6. A Renault V6? Okay. Peugeot, Renault, Volvo V6, Eagle, and Volvo 604 engine, basically. That's kind of what I thought. A 305 tune port motor could make 600 horsepower with boost. I mean, with almost any, with heads and cam and a better tune port, it would do better. But it could easily make 300 horsepower even with a tune port on it. What would the weak link be in the long block once power more than doubles? I don't know. Brian might be a good guy to ask that. Did you finish the distributor adapter? Or are you still planning? I'm gonna run the Holly. That it already ran. We already ran it on the. We already started. We did a stand start on it. We already started it up on the engine stand. So the distributor with basically a hole in the side of it, and then we mounted an LS crank trigger, or a cam sensor, right? Yeah, I think it's a cam sensor. It's a 4X. It's not a cam sensor. Which one? Which one did we put there? I can't remember now. I'm thinking it's got to be a. Well, we can select that on the Holly. It's either a cam sensor or a crank sensor that we mounted there, and then we're just running that. It's going to run in batch. Did you get the head back from David? David Visart? I have not. I haven't even talked to David. I don't even know if he's done with it. Wasn't the 2.2 Chrysler motor a Mitsubishi motor? No, I don't think it was. The 2.2 Chrysler was actually a motor they developed. It started out from something else, a Volkswagen or something, is I think where they got some of the information from. Richard asked about a spark plug gap being closed in my turbo 5.3. I confirmed it was a broke ring gland on the piston. Yeah, I don't see how that can happen other than it being a physical interference thing. Let's see. Somebody may be able to answer this question. I don't know because I've never done it. How hard is it to swap a 4L60E to a 4L80E on the 2003 Silverado? I don't think the physical swap is too hard. I just don't know about the programming changes. David Vizard has the 2.2 liter head flowing nearly 220 CFM. That it just seems like a whole lot. The weak link is tuning. Bottom ends are tough. Non-turbo lightweight rods aren't going to like brutal torque. The earlier blocks are weaker than the 89 plus than the common block, right? Have you heard the rods and crank are forged, but the pistons are cast? I've not heard that. I've read all about the two, or not all about, but I've read all the stuff that I could find on the 2.2 and which years have better rods and stuff. And you know, I don't know that there's anything in there that's forged. You might ask. Brian would probably know. Is that the 2.5 engine that came in the starting Conquest? No, that's a different motor. When I moved the throttle body pre-turbo to post, intercooled hot air Grand National response greatly improved. Was the Grand National a draw-through throttle body also before it was intercooled? Not the Grand National, but it would have been just a Regal, right? Quick question: if I delete the AFM on an LS4 and replace the valley cover with a non-AFM type, yes, you can do it. That's part of the changeover. The 89 T2 had forged crank and rods. Column blocks are heavier and stronger. Even more weight was added after 1990. Column blocks are said to be strongest. 5.3, what boost level would you recommend gapping the rings? Well, can you tell me what the gap is now on the motor? So then we don't know. Stan Weiss has a 2.2 head flowing, 150 to 160 CFM. That seems kind of reasonable. Goodman, the early ones had used that VW engine, but not the 2.2 turbo stuff. Only the Spirit RT had forged pistons, Brian said. The hot airs were draw through. Okay. Kyle, number one, the 2.2 needs to start with at least a Turbonex TO4E Super 50 and 0.82 T3 exhaust. Then we can see the gains from cams and porting. We're going to run it a lot with the stock turbo if that stock turbo is still working. And then I have a few upgrade turbos that we can put on it. .782 heads, peak at 143 CFM. The RT and the Maserati both had forged pistons. So here comes Dean with the VW stuff, right? Early 1700cc Omni and Horizon-based engine was the VW Rabbit, a cut-down Audi 5-cylinder. The whole 2.2 engine was based on the Cricket bore spacing with an overhead cam head. Chris, I've seen ported heads hit 210. Okay, so that's up there pretty good. That's enough to make good power. I mean, that's enough to make 200 horsepower or more NA. Have you ever done a setup with an O2 fooler to richen air fuels on a stock PCM? We did that stuff with Hondas. That's what the VTEC controller would do. You could what was it? The AFM or something would do that, because all it's doing is skewing. I think that they were on that one. They were skewing it was an Apex deal, and they were skewing either the air temperature or the coolant temperature sensor value to add fuel with it, and it does work. Too much fun. Episode 37 of Engine Masters autoplayed on my YouTube with a strapping young lad and Richard making changes before the dyno runs. 100mm throttle body on a hatch, at least, right? Unless you could have two of them. That was back in the days of fuel pumps. I think the FMUs is what you're saying there. Piggyback injectors, no computer tuning. I ran my car out the Silver State at wide open throttle for 30 minutes with an FMU on it and 24-pound injectors. I think it had a 24-pound meter on it also. But if the fuel pressure was pegged at 100 PSI, it was a lot. Hope you're putting in 10-to-1 pistons in the 2.2 so you can take full advantage of E85. We're running stock pistons in it because we want to see what the stock motor will do first. It's not a build, it's a test, like these other test motors. Yeah, the FMUs were interesting because they would, the early ones were like 12-to-1. So for every pound of boost, it would add 12 pounds of fuel pressure. You see how that multiplies up pretty rapidly. Hope you don't damage the head when and if it lets go. I'm not trying to break this motor, not with that head on it anyway. It's surprising how much fun you can have with 24-pound injectors. Yeah, 24-pound injectors and 100 psi fuel pressure will go a long way. Off topic, but have you built a Chevy 267 V6? I mean V8. I have not. I haven't done a 307. I haven't done a lot of those unusual other guys kind of small block displacements. An HMU's one on the helicopter turbine engines. At higher RPM, should I run larger plenums or smaller plenums? I don't know. I've done lots of testing on plenum volume and haven't really seen much of a change in power. So I honestly don't know how to answer that. I know people will there are people out there that will tell you, oh, it's this. Like they'll tell you that plenum volume. Yeah, you got to have that reservoir for when it draws in. I'm like, have you ever measured the reservoir and figured out how much air is in there and how quickly your engine goes through that amount of air? That's not a reservoir. It's not extra stuff that's waiting to go in there. There's no extra stuff. It's gone like instantaneously. So it's not that. It's a resonating volume. It's called Helmholtz resonance, and it's a resonating volume of that common plenum in the air inlet and yada, yada, yada. But I don't know. I don't know that. I've never had anybody show me that on a turbo application, the smaller plenum is better or larger plenum is better. I've never seen a real back-to-back test where that's the only thing that they change. And I haven't done that test either. Richard, I found an L33 in the junkyard today. Someone got the heads already. That's okay. Honestly, I'd rather have the aluminum block and the bottom end, because I'd just go put 706 heads on it. I really could care less about the 799 heads. I would be much more interested in the aluminum block and the bottom end. Try going back to stock turbo once head and cam are improved to see what a stock appearing engine can do. I will run a cam test on the stock head. Well, it'll have springs in it, but we'll run different camshafts with the stock head before we do that with ported stuff. People think you need 600 horsepower if you never had 400 horsepower. I promise you. And especially if you have 400 horsepower in a 2.2 turbo Chrysler motor, that's a lot. That'll get your attention. I have not shipped the 30. Cameron wants to know, hey Richard, have you shipped the 3800 heads to Eric yet? Can't wait to see what he can do porting cast heads. I haven't. They're still in my garage. I kind of decided against that. I don't know if I need to do that. I don't know if that's what I want. If I get a favor from Eric, I don't know if those are the heads that I want him to do. I don't know if the 3800 needs new heads. The ones that are on it, even though I don't think that they're great and they didn't seem to show very much power, we can make enough NA power with those heads and the right cam and the right intake manifold, I think, to get where we need to go. So I'm thinking about that. Eric, yes, that's what I used to think until I saw Richard had shown us about the single plane and the dual plane. The single plane and the dual plane, the power difference doesn't have anything to do, or has very little to do, with plenum volume. Richard, last night you were asking about octane and power. The Engine Masters guys ran an LS3 on 87, 91, 110, 116, 85, all made the same power. Yeah, I've talked to Brule and Freiberger about that many times. I just haven't seen it. If you could change something in the fuel and only change the octane. But the thing is, going from 87 octane fuel to 91 octane fuel, you're not just changing the octane rating. You're actually changing the fuel. So something else could be changing that could therefore change the power. But they didn't really see anything in doing that testing other than obviously the E85. Brian, Stu Davis, a Chrysler 2.2 engineer, tried to get 3 Helmholtz resonance chambers in the turbo 2.2 intake track. He wanted an over the valve cover intake manifold too, but they did not like that idea. Having the long runner in there would definitely help that thing with torque production. Although I think that they were limiting torque production on those things anyway, down at low speeds, with boost and or timing, if I understand the stuff that I was reading about it anyway. Did you design the 3800 with the heads you ported yourself? No, because I only ported one chamber, and then I gave the heads to another company and said, look, I already ported this one. I just need it to be like this or better, hopefully, and it wasn't. .400 horsepower. Michael, 400 horsepower and a 2.2 would be pretty spicy. I had a buddy with a quad 4 and a Fiero, kind of my favorite combination, with about 400 horsepower turbocharged. And it was a blast. That would be a lot of fun. What effect does fuel pressure have on injectors? Does doubling the base pressure effectively double flow rate? No, it doesn't. The change in fuel flow for injectors based on pressure, there's a formula for that online, and you can research it. It doesn't go up anywhere near that. If you say run 80 psi base pressure instead of 40, would that turn a 24 into a 48 pound? No, it won't double the fuel flow. The smart money with a 2.2 is sizing the turbo correctly for the performance you want. Porting won't make much difference. I spins well to $6,000. The gain for dollar spent porting isn't there. Brian, they limited torque with electronic boost control below a certain RPM because they were worried about transmission life, right? 525 trans and the automatic trans. I would think that would especially have been a problem with the Turbo 2.5. Although I don't think that they didn't ever do a Turbo 2.5 version, right? They didn't have an intercooled version of it. Swap the 2.4 from an SRT4 to that can be done. That's a 4-valve deal, and that can make best power. What's the best Porsche? Dan, if Dan was here, he would be able to answer you. There's lots of good ones to choose from. Yeah, no turbo 2.5. I didn't think so. Although I like the 2.5 because I just like the torque that it makes. The bigger one, and then you have boost. And also, if you use the same turbo, which I know that they juggled turbos around in those different versions, but if you had the same turbo on a 2.5 and a 2.2, which I'll be able to test because I have a 2.5 also, I'll be able to do testing on that, and then we'll be able to do some comparative stuff and see which one of those spools of turbo. Big surprise. The bigger motor is going to spool it quicker because we saw that already, obviously, on the 8.1 and the 5.3. But that's what I like about the 2.5 because you can have lots and lots of torque. Mexico got the 2.5 intercooled. That's right. I did remember reading that. But it wasn't rated higher than the 2.2 because of the octane. Okay. My favorite Porsche is the 944. A 944 Turbo is a really good car. Or the 3-liter, I think it was a 968. A 3-liter 968 Turbo would be good. I'd argue that going from a low-octane fuel burning to high-octane fuel without changing anything, the engine would result in a loss of power. Well, that's because you're thinking that octane rating and burn rate are directly correlated, and they're not. That's not a causal effect. They can be, but they don't have to be. You can change the octane without changing the burn rate. Those two things are independent. So just because you go from 87 to 90, or if you go from 91 to 87, the 87 doesn't necessarily have to have a faster burn rate. That's not, I remember talking to the chemist that worked for Union 76 that started Rocket brand race fuel, and talking to him about that. And because that's a common misconception, is that that's the burn rate. The octane rating is the burn rate, and it's not. So see, we learn something new every day. Yeah, Brian, I'm excited about, I have that 2.5, and I'm excited about putting that back together, because I want to see, obviously the cool thing about a 2.5 is then it can make, it'll spool the turbo up quicker than the 2.2, because it's going to make more torque. It's just going to do that because it's bigger. And that means that if you can either have more torque down low than the 2.2 does, or you can put a bigger turbo on it and have the same torque down low, but then have more potential on the big end. Then everyone's going to say, yeah, but the 2.2 is a little one. It's going to want to rev. Yeah. Does engine load create more boost than free revving in neutral? Yeah, free revving in neutral on a turbo might not create any boost. I love my 2.5. My Reliant spools my 50 trim TO4E just fine. Perfect. I think you need 33 to 40 PSI. That's a big spread, 7 PSI, to make 500 horsepower on these due to the head flow. What's the bore and stroke difference between the 2.2 and the 2.5? I think that's only stroke, right? Brian will know, but I think it's only a stroke change. When you hit that junkyard Magnum with nitrous, did you mess with the ring gap? I haven't done anything to the ring gap on the Magnum. Jeremy, do you think a 2.5 turbo 3 double overhead cam is a sensible build over staying 2.2? It'll be a better combination. I mean, it will just make much more average power. I built one, but have not run it yet. I'm not understanding what you're doing, but 3.62 on the stroke on a 2.2 and 409. Uh-oh, we got to worry about piston speed. And you ever play with a GM 1.8 turbo engine? Just picked up an 86 Pontiac Sunbird. Nice. Balance shafts cost horsepower on an LNF Ecotech. GM says it loses 30 horsepower with balance shafts. I would be kind of surprised if balance shafts cost anywhere near that kind of power. Okay, you are gone. I don't know what your deal is, but you're not here anymore. If you want to contribute, you can contribute. And if not, then don't. I think you make a girdle for the bottom end of the 2.2 for pretty cheap. With a two-step on 305, I'm getting 12 to 14 pounds off the line. Just can't keep huge joints together. Yeah, I don't know what the heck. I don't know what the deal is. Just vagueness. Okay, let's check our poll here. Interesting. Is the cylinder head flow the number one thing limiting power production in the 2.2, 2.5 Dodge turbo motor? So 59% are saying yes, that the cylinder head is the thing that we need to change first, obviously. We will end our poll there. So it's about 60-40. Stock, non-intercooled, early 2.2. Use a 60 millimeter throttle body, 3-inch tube to the turbo, no exhaust after the turbo. 195 down at 15 pounds. That's a lot of boost, right? What's the most RPM we've seen on the dyno? I've only run stuff at like 8,000 or 8,500 for anything that I've run, but I'm sure other guys have run stuff higher than that. Should I put effort into the 305? I don't know why you can't make power with a 305. I mean, if we made 375 with a carbureted one, and then you start adding boost to that, it can definitely make power. Obviously, with a bigger small block, you're going to make more power. But if you want to stay with a 305 because it's unique, then you can make power with that. Have you ever heard of them cracking 10,000 RPM at Westtech? I've never asked what the maximum RPM is. Two more minutes. I had a 2.5 Reliant K two-door with a bench seat. I blew the motor with 80,000 miles and replaced it with a motor with 240,000 miles. Well, it's more. That's better, right? Speed went to 85, but the needle went down to mile per hour. That's right. That's what you tried to do. You tried to, if you were good, you could like bend it all the way back around and then peg the speedometer on the backside. That's Populous. I'm glad there's another four banger enthusiast in the chat. There's probably lots of them here. Building my Saturn SL2 LLO to 330 horsepower. Is this a turbo mode? Oh yeah, low to moderate boost. Yeah, just you want to try to, just like every motor, you want to try to make as much NA power as you can. That way you can get your power that you want to get at the lowest boost level, or just add boost. Do you lose power with an oil cooler? Probably not. You might lose oil pressure. Well, you're definitely gonna lose oil pressure with the cooler. Todd's in the house. I ain't no punk. I just walked in the door. I'm getting ready to go. What else is done to the Turbo 2.2? Nothing yet. I have a completely stock one that I want to start from stock and then go up from there. A 305 is awesome. I mean, it's no 302, right? Because we know that that's the one that revs to 10,000 RPM, but yes, the 146 horsepower deal on the 2.2 was 7 pounds. At least that's what they're saying. So Bone Stock 91 Firebird 305. I ran, Katie, I ran one of those, and I think the video's up because I compared a 305 TunePort motor to a 302 5-liter Ford, which is those were the two that were battling in the late 80s. And I think it made 260 something horsepower with headers and no accessories and stuff on it the way that we ran it. Yeah, the head that David Vizard did is good. If you guys haven't seen it, go take a look at David Vizard's stuff. I don't remember seeing any internationals in the wrecking yard that I went to, but I didn't really look. Speed Racer, we would rob starter injectors from the BMWs at the junkyard to put them on the GLS intake. The Dodge that I worked at. Yeah, the one injector for 5 pounds of boost added. That's it. The additional injector stuff, that was really big back in the day. What cam did you use for the D Stroke Ls3? I tried 2 of them. I might still have those cams. I ran one from Billy that Billy did, and I ran one from Brian Tooley. Oh, from dropping up the Subaru, I have to go over and see if I can get the Z71 tonight. If you want to do it on another day, let me know. If it can't be done tomorrow, I'm free tomorrow morning through some of the day. I can't go up there in the afternoon and do it from afternoon to night, but I can do it from the morning to the afternoon. So if that works, and if not, we'll do it another day. I just made 280 horsepower at the wheels with the Nissan VG33 with a little stock T3 turbo on it at 14 pounds. Peak torque was 2,500. That must be a small turbo. Braden, it's always the wrong cam, right? So I think I already said 2 more minutes though, right? I think I did. Okay, guys, I gotta get going. It's been longer than 2 minutes. It's Saturday night. It's time to do stuff. It's time to do like Saturday night style stuff. Oh, I wanted to cover the stuff that I wanted to sell too. Dang it! I'll show you that. I'll show you guys that stuff really quick. Here, who needs this? Who needs this? Who needs? Ta-da! Look at that. That is an LS 671 blower intake manifold. So if you're looking for one of those, there's one right here. I have one available. My email is in the video. And the other thing I'm trying to sell is this. I need to get rid of this. I never use it. It just sits around. This is a Ford FR500 intake manifold. So if you're interested in that, look at that. It has the IAC motor and the EGR. It's a dual runner deal. Here's the controllers back. I don't have the controllers, but look, wah, wah, wah. It's a dual runner deal. Long runner, short runner. And it's made of magnesium. I have to hold it down with rocks because otherwise it will float away because it's so light. So if you guys are interested in that, let me know. I have my email, and I'll put it right here just in case. I should have done that right away after I did the poll. I need to introduce that stuff. So if you guys know anybody that's interested, let me know. If you're trying to put a 671 on an LS, that will help you do it. And probably you could, I'm imagining with a small adapter plate, put almost any blower on there, almost any root style blower on there if you wanted to do that. It has provisions for injectors. Yes, it has that. So let me know if you guys are interested. Thank you guys all for showing up, and I will see you guys all tomorrow. Let's see.